Hello, I'm Amy and I am in the Ableton User Group here in the Central Goldfields of Victoria, Australia. And for our October meetup in our group, we were lucky enough to be joined by Steffan Ianigro, who has developed an incredibly cool non-linear LFO device in Max for Live. It's called Plecto and it was part of his PhD project for University of New South Wales. Steffan explores biologically inspired computing and the notion of computational creativity, which is incredibly interesting. He uses that as an active musician. He's performed at Vivid in Sydney and with the ensemble Offspring and a lot of other things as well. He walked us through the LFO device as part of this session, the development of it, which is completely fascinating. But also I think the big thing to take away from it is the creative potential in this device. It is completely user-friendly. You can really get down to the bones of it and make it your own, build your own device out of it. He's been very generous in the way that he's developed it. It's a really, really nifty device. It's a lot of fun. So you're going to want to download it. It is in beta at the moment, so free to download. So go to Plecto, Google Plecto and you'll find it, or you'll find it in the comments below, and have a play. Enjoy the session with Steffan.
Cool. So yeah, as you know, my name's Steffan. So I'm currently a PhD candidate at University of New South Wales, and I also work as a software engineer. So really, today I'm just going to give you a bit of a background about myself, about the device I'm making as well. Talk a bit about the device functionality, and then do a bit of a demo of its capabilities. And it's one of those devices where there's no real, this is how you need to use it, and these are the configurations you can use. It's very much exploratory. You can map it to any parameter you choose, and you can link them together, do whatever you want with it, and hopefully achieve some interesting sounds. So a while ago now, I did my composition degree at the Conservatorium of Music. So I started out writing compositions for like acoustic ensembles and things like that. And then I just got really interested in programming, for the reasons being you don't have to rely on other performers, which can be very expensive sometimes, and sometimes unreliable. And obviously using technology, you just have a boundless array of sounds that you can use to create as many layers as you want. This was really interesting from like a programming point of view, where you could build all your own devices as well. So if you weren't happy with the out of the box devices that you can use, you can just build your own. So I also started getting really into like improvised electronic music performances as well. So I really like that interaction with the audience and being able to sort of, adjust your soundscape as you're going. And yeah, so I started my PhD, I think 5 years ago now. So I'm doing it part-time, and just really looking into how computers can aid musicians, specifically around evolutionary algorithms and neural networks, but I'll get a bit into that in a sec. So one of the big challenges in electronic music is achieving gesture. So, with playing a violin or a guitar, it's quite easy to impart gesture when you're performing, but in electronic music, sometimes things can sound a bit cold unless you spend a lot of time, writing things like, automation. But this can be a bit challenging for live performances because you're kind of stuck with certain effects. Also, you can build these massive, live sets where you have plugins everywhere to achieve, quite complicated sounds and textures. But again, managing that complexity can be quite hard, and it sometimes can be quite CPU intensive in Ableton. There's some really great conferences around people building instruments themselves as well. There's one called New Interfaces for Musical Expression, where people are just exploring all different ways to make instruments to achieve different levels of interaction and gesture. So there's also many out-of-the-box tools as well, which can be learned and used effectively. But still, I found, during my own practice, it was hard to control lots of different parameters at the same time, while achieving, gestural control. I'm often ended up using randomizations and things like that. But if you're doing like long drawn out textures, it can get a bit tedious sometimes because there's no real longer term structure there. And also, if you want these really specific interactions, you kind of have to build your own instruments. That can be a challenge in itself and quite time consuming to do. Other people are just going the complete opposite direction and discarding any human interaction and building systems that are like these black box systems that ingest an input, and then they'll go and do something and produce some musical output. And my supervisor, Ollie Bowen, he made a system called Zamutin that does this, where you can perform with it and it will produce a bunch of sounds back and improvise with you. But again, as a performer, you kind of want that trajectory or that control over that, soundscape and the way the work is going. So, for my own practice, it wasn't as sort of interesting. So I started my PhD trying to solve some of these problems, and I was really into this idea of evolutionary or genetic algorithms. So they're based on Darwinian theory, and without going into too much detail, they can be applied to the musical domain in some quite interesting ways. So, for example, a few people have evolved synthesizer sounds using these optimization algorithms to find specific sounds, or just explore the sound space of the synthesizer that may be more difficult to do if you're just tweaking knobs and things like that of the device. And I remember when I started my PhD, my supervisor said to me, you could either go down the easy way, or not the easy way, the more well-known way, where you could just evolve synthesizer configurations and things like that that already exist, or you could go down the crazy way of evolving these things called continuous time recurrent neural networks. So this is a type of neural network. They can be trained to do certain things, so they exhibit some like cognitive behaviors. But one of the most interesting things about them is they can just produce these really bizarre nonlinear oscillations that, seem to have a lot of potential when applied to the musical domain. You can then also discover configurations of these types of neural networks using evolutionary algorithms as well. So that really aligned with the sort of research area that I was looking down. So I initially explored these more for actual signal generation, so using them as like audio effects, actually as synthesizers themselves. But it was a bit of a struggle to do. They were quite chaotic. And then I was chatting with my supervisor and sort of had a bit of a brainwave and saying, well, why don't we actually, instead of running them at audio rate, run them at a control rate and use them as an LFO, which you can then map to different parameters within Ableton Live. So there are lots of out-of-the-box LFOs that you can use. For example, the Ableton one, you can, change all sorts of different parameters using sine waves and things like that, and also introduce some randomness into the process as well. But again, there was that challenge of when you're doing sort of these long-term textual works and things like that, they can get a bit repetitive unless you can chain them together and do all sorts of interesting things. But the CTRNN seemed really interesting as potentially using as a core for an LFO. So first of all, I started, I was very much involved with sort of max MSP generation for my earlier compositions. And so I made a little Plecto external that leverages this type of neural network. And then you can load configurations into it, and it'll produce 6 outputs, which you can map to whatever fields you want within max MSP. And then taking that a step further as well, actually implementing a Max for Live device that has this at its core. So making it much easier to integrate within Ableton Live, and most importantly, much easier to integrate into existing workflows of practitioners. Because at the end of the day, I really wanted this device to be used by other people and enhanced by other people as well, because there are a lot of open source components to it. So pretty much the device, currently, there's a configuration loaded in this image, and each of those outputs you see are the 6 output nodes of the neural network. But because an evolutionary algorithm is used to discover these outputs, there are potentially thousands and thousands of them that you can use. So there is a web interface where you can actually explore about, I think, 800 of them that I have discovered using an evolutionary algorithm and just load into the device. The interesting thing as well with them is that each of the outputs can be correlated to a degree. Sometimes they won't be correlated at all, but sometimes they will show very similar behaviors. So that can, introduce some quite interesting mapping considerations there. You can change the range and offset of them, but out of the box, if you click map to a parameter, it will automatically map to the range of the parameter you've selected. And probably most importantly as well, the output is completely deterministic. So every time you run the device, so you can sync it to your transport, it will do the exact same thing every time. So there's no randomness in there. So yeah, every time you run your live set, you can even loop them as well. So I can say I want the neural network to reset every 4 bars or so. So you can actually sync them up with your loops that you're doing. And again, it'll produce the same behaviors every time. Currently, if you download the device, it will look slightly different to this. And there's only a 1-to-1 mapping between LFO and parameter you want to control. But today I'll actually release the new version where you can actually map each LFO to 6 different parameters at one time. So that's really like an overview of the device. Also, it has an online interface, so you can go into the app, you can create an account, and you can save different neural network configurations that you like to your profile. And to sync them with the device, all you have to do is type in your profile name and click the sync button, and then it will automatically load them into the device for you, and that will work offline as well, so you don't need an internet connection to use it. So I'll get into a bit of a demo of the device if there's no questions. Cool.
No, I just want to see how it works.
Cool.
That's cool.
So I've just been playing around with a glitch sample pack. So I've come up with a very simple live set over here, just sort of trying to show a bit of the behaviors that you can achieve with the device itself. So currently my transport's off, so I have nothing playing, but if I did, I can start this transport now. So I've got all my tracks muted. So I just wanted to talk about the device a bit within Ableton Live. So here's a device running. We can see it's producing all these different LFOs. And if I wasn't syncing with my transport, these LFOs will keep running and keep changing continuously over time. So if I came back in half an hour, they may be doing something completely different to what they were, at the start. Saying that, if I did run it again, it would do the exact same thing half an hour from now. But this one here, I've actually synced it with my transport. So if I stop it, it will just sort of flatline. And I've also said I want it to loop every 4 bars. So if I play the device again, I can see it started doing some crazy things. And then every 4 bars, it will then automatically reset. So in this live set, I'm mainly sort of dealing with loops and things like that and controlling parameters of those loops. So I'll be mainly setting it to sync up with my transport. However, I do have a little vocal drone thing that I'm letting it just run free when I start the actual live set. So listen to some terrible music now. So if I unmute my device, so I've just got some glitchy drum sounds there, and I've turned off this little delay that I've got currently configured on the channel. So this delay, I've got the frequencies of all these filters, and these are controlled by 3 different oscillations. So I've got one here controlling my filter frequency 1, so that's this one over here. I've got one over here. I've got one over here, changing my filter 2 frequency over here, and then I've finally got one over here, changing my filter 3 frequency. So these will just gradually move and change over time. So I can enable this. And the reason behind adding this one now is just to create a bit more of a interesting effect on the drums. Obviously if this was a more in-depth performance, I'd probably do a bit more funky things with the device, because you can map these to multiple parameters as well. But I'll demonstrate that when we start sort of introducing more layers into the work. So I can turn it off just for comparison. There. So one of the things to note as well is these devices actually accept an audio input. So what actually happens is this audio input gets analyzed and fed into the CTRNN as well. So what will happen is depending on what audio you're playing, will actually affect the behavior of the CTRNN as well. So you can get some effects similar to side chaining and things like that, where your audio changes the behaviors of the LFO, which in turn would then change parameters of other devices and things like that. Sometimes, depending on the configuration used, it will ignore the input a bit, and other ones will be much more responsive. So that's just part of that exploratory process of finding the configurations that really meet your sort of creative needs. But I'll get to the web interface where you can sort of search for different configurations a bit later. So now we've got the drums. I've got a little pad. So this pad, I've again got another LFO, so you can have as many of these as you want within your live set. They're not very CPU intensive as well at all, because they are running at control rate, and the neural networks are generally very small. So often with neural networks, to train them is very computationally expensive, but to actually run them is quite easy. So the training or discovery process of these configurations happens in the background. Running the actual LFO itself is quite easy on your CPU. So over here, I've just got a little pad, and I'm mapping, a few of the LFOs to certain fields. So I've got this one mapped to a filter frequency. I've got another one mapped to filter frequency 2, and then I've got another one mapped to my filter resonance as well. So I can introduce that into the mix now. So with this one, probably the most interesting audio effect it produces is changing my second filter frequency. So you get a nice sweep happening there. So what I also want to do is, if I want to maybe accentuate that a little bit more, I've got a little like one-shot sample thingy happening here. And what I've done is I've got this particular LFO controlling this filter 2 frequency. So what I can do now is map this to another track to control, completely different parameter, but it will actually correlate to this sort of filter sweep behavior. So over here, I've got it set to my filter drive. I think that's the one. Yeah, filter drive over here. So I can now introduce this. So yeah, so the actual device itself, when you map these, it will automatically map all your ranges and things like that for you. So you can map this LFO to as many different parameters as you want, and it will automatically map to all the different ranges and things like that. So it can be quite fun to use, where you can map a single LFO to completely different parameters of your live set. And as you run them, they'll all sort of sound somewhat correlated. And you can also get similar effects if you use other LFOs that also have slightly similar behaviors. You could even use one LFO to control your whole live set if you wanted. So off the back of that, again, I wanted to sort of extend that filter sweep sound a little bit more. So again, I've got this little cheesy melody here. So I've mapped it as well to this the first oscillator filter. So I can introduce this as well. repetitive after a while, but you know, it's quite a simple live set. So but you kind of, I suppose, get the idea of that whole looping situation where on the drum rack, I'm controlling this delay effect, and it's looped every 4 bars, but I wanted to get a bit of an offset now and loop this one every 8 bars, so you can play around with that as well. So I've got my melody, I've got, you know, a pad and a few sort of drums happening as well. I used to do, and I still do a bit of it, but a lot of drone manipulation and things like that. So this is a device I made ages ago called the Drone Machine, cheesily enough. But I haven't released this or anything like that. It's just mainly used for my own performances, but all it really does is take a sample, window it, and layer it over itself. So it's kind of like a very simple granulator almost. And then I've recorded, I've got a bit of vocal here, and what it's going to do is just sort of create this drone. And over here, I've got the loop sync turned off. So I've just got the transport sync turned on. So what will happen is once I start my transport, it will you know, enable this LFO, and it will start doing its thing, and it won't loop or anything like that. It will keep progressing throughout the live set. So through some configurations, you'll find that once they start, they'll fluctuate quite rapidly, and then they'll eventually die out and fade and eventually start just becoming very static. Other ones will just keep changing over time and then start doing weird fluctuations. And what will happen is if you feed audio into them, they'll sort of kick back into life again and, you know, do things like that. So what we've got here is this LFO. I've got 2 of the outputs here, and these are mapped to the actual like windowing of the sample. So over time, it will just sort of keep shifting and changing the actual windowing of the sample drone that's being played. I used to randomize that a lot, but after listening to it for like 5 minutes or so, or even longer, which a lot of drone works do, the randomization can become sort of a bit repetitive in its own right. So using this LFO, I found that, you know, say 10 minutes down the line, it will start doing something completely different and create sort of new textures without really having to do anything as a performer. So that means you can have, you know, 20, 30 drones all happening, and they'll all gradually shift and change over, you know, that 30-minute period or whatever you want. And you'll get some sort of semblance of structure there, or longer term structure automatically. It can definitely be enhanced a bit more as well. So I want to do a bit more work in terms of modifying the actual optimization algorithm used to discover these configurations to categorize them a bit more into different musical behaviors as well, but that will come a bit later, hopefully. So I'll introduce this drone as well, or I can solo it first just to get an idea of it. And embarrassingly enough, it's my own voice. So we'll see. So what I did as well is to just get a bit more interest in the sound, I've got another little delay on it. And again, that's mapped to the upper end of the sample selection and the lower end of the sample selection. So as it moves up and down the sample, it will also change the filter padding. So we can just include that. So that's just a gist of the very simple little work there. But I just really wanted to sort of highlight that without any automation or any other configuration, it's quite easy to get sort of more temporal gestural behaviors happening. And you can really extend on those as much as you want because, you know, it uses the live object model where you can map, you know, these oscillations to any sort of parameter of Ableton Live. Also, it comes with all these, you know, default configurations here. Some of them, like the names are maybe a bit confusing because they all sort of have some similarities, but I try to sort of categorize them as best I can. But what you can do is, if you're really sick of them and don't like them anymore, you can jump onto the website. It's got a bit of, you can download the device here. It's got a bit of a tutorial there where it will tell you a bit more about the device, which I'll update once the new release is done. It's got a dashboard as well, which I'll get to in a minute. But as I mentioned before, it was really important to sort of encourage that open source side of things as well. So there's a bunch of code that you can actually download and use and hack if you want. So first of all, there's the Max external. The code for this isn't actually released yet, but you can use the Max external and build your own Max for Live devices if you want. And there's also an example patch which you can open up, and it will just give you some instructions on how to get it running and producing some oscillations. There is also an NPM package. So if you're a Node or JavaScript programmer, you can utilize this, and it's a CTRNN library. And there's also one for Java and C as well. So if you want to get really nerdy and into that, it's definitely there to use. Furthermore, like one of the hard things is to actually access these neural network configurations because they can be quite big. And they actually are quite hard to find sometimes. You do need some sort of optimization algorithm to do it. So there's actually an API as well that is publicly facing. So you can set your profile. So I'll set the default one, but you can just chuck it in your browser and it will return the neural network configurations that actually fuel the Max for Live device as well. But when you do load your actual profile, what it does, and you press sync, you'll actually download those from the API for you and just save them within the directory of the device. So then you can just shut it off, shut your internet off, or if you're doing a live performance somewhere, you can just have them all ready to load and ready to use. So I can demo that now actually. So I can jump into the dashboard. The device is actually my local, my own one, but I can see here I've got all my my default profile, which aligns with the default profile configured in the device itself. And I've got all these ones configured here, which I've just liked and saved against my profile. So if you create an account, you can call your profile whatever you like. You can share it with your friends as well, and that will appear blank. So if you want to find new ones, this actually uses the JavaScript library, and you can say, I'm going to click on this neural network, and it will actually render the output for you. So you can preview all of them as much as you want. So if you find this one, and I don't know, maybe it looks quite cool, you can just call this one crazy, spell it right, and I can just add it to my profile. So now it's stored here on my online profile, ready to use. So if I go back into live, currently it's not there. All I need to do is just click sync. And now I've got my crazy one here. You can click on it, and then now this one's mapped to my LFO. So I'm just getting a different behavior there. Between the first and second outputs, where the ones before were a bit more different in terms of the actual LFO outputs themselves. For once my voice dies in the background. That's a general idea of the device and sort of how it works. I've tried to display these configurations in a way that make some sense to actually navigate. But as I said, there's quite a few of them. You can zoom into them and sort of preview them, but I really want to improve this, interface a bit more, make it a bit more easy to find configurations that may be applicable to sort of drone treatment, to more loop-based work. And that will just come down, I think, to the analytics of the actual outputs themselves. So I suppose watch this space. I'll keep improving it, keep enhancing it. And if you've got any feedback or struggling to use it, just let me know. And also preferably if you're really loving it and you've got something that you've made with it and you want to share it, I'd love to hear it as well.
Can I ask, with the default settings that you've used, so the chaotic and correlated, those configurations, can you give us an example of a few, like what they do, what the differences are in just a couple of them? So for anyone who's getting it, who's just opening it for the first time, if they want to do something specific with it or get a certain sound, they might gravitate to one of those settings.
Yeah. So it has been quite actually difficult to categorize them as well into different behaviors, but this was more just my loose categorizations of them, where this one, the behaviors are sort of much smoother. So if you're sort of dealing with maybe more drone or textural treatment, this would probably be quite an interesting one to use, because it would more gradually change and gradually evolve over time. You know, we can see these little oscillations appearing here, and maybe you could use this to control lots of different aspects of a single live set, because they're all quite correlated as well in their activity, and yeah, they have sort of quite smooth gradual changes. One thing I forgot to call out as well is in the device there's this rate parameter. So if you're you know, playing this little vocal, I'll just decrease the volume a bit, and you wanted to speed this up, you can crank up the rate. And that's not just changing the how many times, or the control rate, it actually changes the time step. So it's almost like a physics simulation. If you have a ball that's bouncing around, if you increase the delta time, it will increase the speed of that ball bouncing around, and it may do different things. It's the same with a neural network, where if you increase the rate, it may actually do slightly different things as well, but most of the time it will just correlate to speeding up the behavior that you are otherwise seeing. So you can play with this as a parameter as well, depending on what you actually want to manipulate. So over here, if I did want to increase the rate a bit, I could do that. But again, this configuration is still quite gradual in how it changes and things like that. So again, probably more for, you know, textural changes or more broader parameter control stuff. If you just want to go a bit crazy, there's a chaotic one you can use, and especially if you increase the rate, you know, it's more chaotic, I suppose. You know, we'll start oscillating a bit. You can change your inputs as well, and sometimes I'll just switch state completely. See over here, it's starting to do some weird, like, jagged stuff now. So this one will just be a bit more unpredictable, maybe controlling more sporadic effects and things like that. But again, these are very loose categorizations, and they're sort of quite, you know, just based off my observations. If you go in and explore some, you'll definitely be able to find ones that in line with, you know, your sort of compositional process. And if you can't find them, just yell out, and, you know, it can help you with that process. But yeah, so you can create your own profiles, you know, call them whatever you wish, and then you can directly sync them with your device. And as with anything, once you save your device, it will save your profile for you. So as soon as you load it again, it will just produce the exact same behavior as you had before. It will save your config selection, any transport, and loop syncing you have on as well. So yeah, you should just be able to reload your live set, and everything should work as it was left off, because as I said, there's no randomization here. It's all deterministic.
And how many in the loop sync? What parameter? Oh, it goes right up to 24.
Yeah.
Does it?
Yeah, it goes all up to 24.
Okay.
So again, that's super easy to change. You could always change it yourself if you just wanted to jump into the Max Live device and do it. You know, I try to make the Max code as readable as possible, just so you can go in and extend it yourself quite easily. But yeah, so that's just a simple parameter. You can just change the select menu in that one to add as many as you like.
Yeah. And you were saying earlier that there's been over 1,000 people have downloaded it so far. So I'm wondering, has anyone mapped it to anything unexpected? Have you got that kind of feedback where they're just like, they've done something with it that you hadn't intended or thought about?
So I'm hoping still to get some more, feedback of, hey, I've made this work, have a listen. I haven't really had many of those yet. And the ones that I have, yeah, it's quite interesting how different people use it. I think with any software, once you release it, you kind of assume people will use it in certain ways, and then you get everyone using it in these completely different ways, and really pushing it to its limit, which is at the end of the day what I really want to see. So as part of my PhD, I really want to do a user study to do more focus groups and asking, those questions around it, just to understand a bit more how people are using it, what they're using it for, just so I can improve it a bit more, and really cater it to what people want, I suppose.
And in your own work, I'm just wondering what kind of musical events and things are you working on at the moment?
So I've got, I'm actually spend a lot of time more in the development space than the actual music making space, because a lot of the PhD has been quite intensive so far on the more theory side of things and working out what the hell I want to use this neural network for. But now that's sort of crystal clear in my mind, which is good. And so really being able to sort of now map this and explore it myself is actually quite an interesting process. So I've done like a more drone-based piece, and I'm using it to do sort of similar stuff where it's more just sample windowing and other effects added on top. But now I'm, getting a bit more into more beat-driven stuff. So I'll just be playing around with that side of things, which will be fun.
Great. Does anyone else have any questions? Can't see any of you. You're all hiding. Everyone's there, just listening. Has anyone got any more questions for Steffan? Nick, I thought you'd be right up there. No?
I missed the beginning, so I might have missed some crucial content. But
yeah, sure.
Cool.
I'm recording it, Nick, so you'll be able to go back.
Sweet, thank you.
Because I think you'd be right into certainly the methodology behind it with the neural pathways. Really interesting.
Sorry, maybe I do have a question. Has anyone? 1 second, sorry. Sorry. Have you seen anyone using like the JavaScript implementation in anything yet?
No, I haven't. So it's a standard node package, so you can use it on the front end or back end as well. So on the front end, I've used it to render the configurations in the browser. Also, it's used in, for some strange reason, I wrote the evolutionary algorithm in Node.js as well. And that uses also the NPM package to actually render the configurations to see if they are any good or not. It's actually like a novelty search algorithm. So all it does is it sort of finds new configurations. It works out if they're actually novel compared to the existing configurations that are there. And if they are novel, it will add them to the population and just keep going. So you could run that for days and days, and it will keep sort of filling in the different pockets of the search space, depending on that neural network configuration. So those are the only two uses I've had so far. But, web audio implementations are quite interesting as well. If you want to render them at, audio rate, you can use your script processor nodes and things like that to do it. There are lots of possibilities for it, and potentially network music as well, which would be really cool to have, neural networks feeding into one another.
Cool, that's fascinating. Thank you.
Yeah, I think you've mesmerized everyone, Steffan. Corey's saying he's loving it, no questions, and Sarah's saying just so fascinating listening. I think it's this is one that you have to jump in and just play around with. I'm curious, how long have you left it running? before?
I've left my live set running for quite a while, but in terms of sitting down and observing it run, I'm not actually sure the longest that I've seen it go on for. It'd be interesting to do some like recordings of the longer term time
That's
lapses.
exactly what I was thinking, to then go back and then sample parts of it later would be really cool, to resample stuff that, you know, happened at 80 minutes in, where it's just like this moment of Vivaz, where you're just like, wow.
Yeah.
That's cool. Yeah.
I'm also really keen as well to explore the input side of it a bit more as well, because currently some of the configurations will not respond to changes in the input as well as others. So I really want to explore that a bit more and make that a bit more transparent, I suppose, on how that actually works and the input affects the configuration. So
what inputs are very, does it work really well with, are you finding?
I think generally drums, like nice, you know, gutsy drums, like if you feed them in, you will often see correlation between the LFOs and the actual drum sounds being produced.
Okay.
Often it will just sort of, I don't know, give the neural network a nudge, so to speak, where it will just sort of spark it into a bit of activity. So it's actually quite nice to then map those to other parameters like, you know, drones or effects and things like that to get, you know, that sort of side chaining effect almost happening. So yeah, I just really want to explore that a bit more and make that a bit more transparent in the next version too.
Yeah, it's got so many possibilities. I'm pretty sure everyone's sitting there just, yeah, like Nick's just written, everyone's probably playing with it. And I think that that's probably true. They've got the video off because they're actually adding it on now, which I don't blame you, because yeah, as soon as I saw it, I stayed up way too late playing with it.
That's good to hear.
And, yeah, and I love the idea that you can map it to like the same thing, so that you're getting that continuity of sorts throughout your set. That's got so many possibilities of sound design wise, like of just pulling those things together in certain ways is wonderful. It's a very cool device, Steffan. And yeah, has anyone else got any last questions? No.
I just stress as well, like this is a yet to be released version, which is the one-to-many mapping one, but I'll have it on there tonight, ready to use. So
that you're in the midst of uploading the.
Yeah, I was meaning to get it done before today, but I just haven't had time. So it's all ready to go. I just got to just freeze it and chuck it online. So I'll do that tonight.
Great.
I have one quick question. What sort of where do you find resources for like learning Max for Live? Like I found intro stuff easy to find, but really developing and honing in, where do you learn about that?
So at the uni I went to, they had a Max MSP course as part of it, or it wasn't specifically for Max MSP, but that was really the main sort of creative programming tool taught. So from that, we did a lot of the basic tutorials, and you know, the help files are great and things like that, just to play around with them. But then, you know, if there were any more advanced applications, there were sort of some teachers to ask or to show us those applications as well. The forums are really good as well. If you're unsure of how to do a certain effect or something on those lines, chances are someone's done something similar before. And so if you just chuck that into Google, the Max forum's actually really good, and there's sample patches and things like that that you can download. So normally if I'm trying to do something and I feel like there's potentially a way to do it in Max MSP, I just jump on the forum and do some searches, and there's a lot of sample patches that are often really helpful to actually you know, learn how everything fits together. To do a lot of the live object model mappings and things like that, I just looked at a bunch of other devices and how they do it. because there's not always an online resource that tells you everything about it and all the sort of challenges you'll face. So a lot of it's a bit of trial and error, poking around, seeing what other people are doing, which is really the beauty of Max for Live devices, where you can crack them open, see how they work, and modify them as much as you want.